Hi, today's reading is Train Circular 9237, Chapter 8, Electrodes and Filler Metals, Section 1, Type of Electrodes, and we're going to zoom in one more time on this. Covered electrode, general. When molten metal is exposed to the air, it absorbs oxygen and nitrogen becomes brittle, otherwise preserved, adversely affected. The slag cover is needed to protect the molten sulfur, solidifying the welded metal from the atmosphere. This cover to be obtained from the electrode coating. With the composition, electrode coating is determined usually as well. With the composition, deposited weld metal electrode specification formulation. Electrode coatings is based on the welded established principles of the metallurgy, chemistry, and physics. The coating protects the metal from the damage of the stable life of the arc, improve with the welds in other ways, which include smooth weld metal, surface even edge, minimum spatter adjacent to the weld, stable welding arc, a penetration control with a strong, tough coating, and a easier slag removal to improve the deposition rate. Metal arc electrodes may be grouped or classified as bare thin coated electrodes, shielded arc, or heavy coated electrode. With the covered electrode must be popular type of the filler metal used in the arc welding composition. Electrode covering determining usability of electrode composition with the deposited weld metal specification of the electrode. With the type of the electrode usually depends on the specific properties required with the welded deposit. This include the corrosion resistant ductility, high the tensile strength, the type of the base metal to be welded, the position of the weld with the flat, horizontal, vertical, or overhead, and the type of the current polarity required. Type of electrode. The coatings electrode with welding mild and low alloy steels may have from 6 to 12 ingredients, which include cellulose provided with a gaseous sealed reducing agent, which gas shield that's surrounded with the arc is produced by disintegrating cellulose metal carbonate for the adjust for the basicity of the slag to provide with the reducing atmosphere of the titanium dioxide to help the highly fluid but quickly freezing slag to provide ionization of the arc and magnesium ferrosilicone to help deoxidize molten metal with a supplement with the magnesium content, silicone content, deposited welded metal, clays, gums, and then provide with elasticity for extruding plastic coating metal with the help provide with the strength of the coating of the calcium and all right, just put it there.
No, it can't be hooked up.
Put it on the table.
It's your title and everything.
Put it on the table. All right. Where were we? Clays and gums have the elasticity extruding plastic coating material with the help of the provide with the strength of the coating of the calcium fluoride to provide shielding after to protect the arc and for the basicity of the slag to provide fluid solubility metal oxide mineral silica to provide slag to give it the strength of electrode coating of the alloy metals including nickel, molybdenum, and chromium to provide with the alloy content of the deposit welded metal, iron, magnesium oxide, adjust fluidity property of the slag and help stabilize the arc and iron powder, increase the productivity providing the extra metal with the deposit of the weld. Principal type of electrode coating for the mild steel with the described below with the cellulose sodium EX10 electrode the type of the cellulose material in the form of the wood floor with flour reprocessed low alloy electrodes add up to 30% of the paper 30% paper. The gaseous shield contained with the carbon dioxide, hydrogen, reducing the agent for the gas stand for the produce for the digging, or with the provide with a deep penetration weld deposit and somewhat rough and spatter higher level other than electrode. It does provide how extremely good mechanical properties, particularly with after aging. And this is one of the earliest type of electrode developed for the widely used cross-country pipelines using downhill welding technique is normally used with the direct current electrode positive reverse polarity. Cellulose potassium electrode very similar with the cellulose sodium electrode, except for the more potassium than used in sodium. This provides ionization of the arc, makes the electrode suitable with welding. Alternating currents for the action of the penetration would result with a very similar to inputs. Both the E6010 and E6011 electrodes, small amount of the iron power may be added. The stabilization will slightly increase the deposition rate. Your rutile sodium EXX12 rutile titanium dioxide content relatively high respect over the other component of the electrode, especially with the appealing to the welder. Electrodes we have the coating with a quiet arc are easily control slag, low level spatter. Weld deposit will have the smooth surface penetration will be less than the cellulose electrode. The weld metal properties will be slightly lower than the cellulose type of the types of the electrode provide with a fairly high rated deposition. It has a relatively low arc voltage and can be used with the alternate current and the direct current with the electrode negative straight polarity. Rutile potassium or EXX13 electrode coating of with a very similar rutile sodium, except for the potassium UV that provide with the arc ionization. This makes it suitable for welding alternating current and can be used with a direct current, either polarity produced with a very quiet or smooth running arc. Rutile iron power EXXX4 coating of the very similar rutile coating with the mentioned above, except for the iron powdering is added. The iron content is 25 to 40% of the electrode of the EXX14. Iron powdering content 50% or more of the electrode EXXX24. Lower percentage of the iron power of the electrode can be used in all positions. Higher percentage for the iron paler can only be used with a flat position, making the fine horizontal fillet welds in both cases. Deposition rates increase based on the amount of the iron powder of the coating. Low hydrogen sodium EXXX5 coatings containing with a high proportion of the calcium carbonate, calcium fluoride, are called low hydrogen lime ferritic and basic type of electrodes. In this class, coating of cellulose clays, asbestos, and other minerals are contained with combined with water not used. This ensures the lowest possible hydrogen content of the arc atmosphere. The electrode coating are baked on a higher temperature for the low hydrogen electrode family has a superior weld metal that provide with a high ductility. Any of the deposits of the electrode have the medium arc or the medium moderate penetration. These have medium speed deposition but require special welding techniques for the best result. Low hydrogen electrodes must be stored with controlled conditions. This type is normally used with a direct current of electrode positive with reverse polarity. Low hydrogen potassium or EXXX. The type of the coating is similar to low hydrogen sodium except for the substitution of the potassium for sodium to provide the iron arc ionization. The electrode is used with the alternating current and can be used with the direct current with the electrode positive. The reverse polarity of the arc action is smoother and penetration of the two electrodes is similar. Alright, 9. Low hydrogen iron powder, EXX28. The electrode is similar with the EXX18, but has 50% more iron power with the coating with it usually only when the welding in the flat position, making horizontal fillet weld with a deposition rate with the higher than the EXX18. The low hydrogen coating with all the higher of the alloy electrodes, and in addition, with the specific metal coating with these electrodes become the alloy type. Fixed letters as used to indicate welded metal composition. Electrodes weld stainless steel as low as hydrogen type. The iron oxide sodium EXX20 coating with a hydrogen oxide content as well deposited with a large amount of slag that can be difficult to control. This coating type of produced with a high deposition rate, provided with medium penetration with a low splatter level, resulting welding has smooth finish. The electrode with usable with a flat position weld to make it a horizontal fillet weld. The electrode can be used to alternating current direct current with either polarity. Art 11, iron oxide, iron power, EXX27. The type of electrode is similar to the iron oxide sodium type, except that it contains 50% or more iron power. The increased amount of the iron power greatly increase with the deposition rate with maybe with the alternating direct current over the either polarity. There are many types of coatings other than mentioned there, but mostly usually a combination of these type of the specific applications, such as the hard coating, hard surfacing, cast ironing, and the non-ferrous metals. Your classification storage of electrodes referred to paragraph 525 of the classification storage electrodes. Deposition rate. The different type of electrode with a different deposition rate with the composition of the coating of the electrode coating of the iron power over the coating of the highest deposition rate with the United States with the percentage of the iron power is in the coating of the 10 to 15% rate with the base of the amount of the iron power with the coating of the version of the coating of the weight with shown in the following formula. Iron power is equals weight over the iron power times 100 over the total weight of the coating. These percentages relate with the requirement of the American Welding Society specifications. European method of specifying iron power is based on the weight of the deposit weld metal versus the weight of the bare core wire consumed. This is also shown as iron powder over the welded deposit metal times 100 over the weighted bare core wire. This weight of the deposit, for this, if the weight of all the deposit with double the weight of the core wire, it would indicate the 200% deposition efficiency. Even the amount of iron power in the coating of the representative of the 1/2 the total dispute with 30% of the iron power formula with the U of the United States will deposit 100 or 110% of the deposition efficiency using the European formula with 50% of the iron powder. Electrode figured in the United States with the same with the produced efficiency approximately 150% from the European formula. Light-coated electrodes. Light-coated electrodes have a definite composition. Light coating has been applied with the surface of the washing and dipping, brushing, spacing, spraying, tumbling, and the wiping of the coating to improve the characteristics of the other extreme. They are listed under the E45 series of electrode identification system. Refer to paragraph 525. The coating generally serves the function of the described below and dissolve the produced impurities, oxides, and sulfur and phosphorus. Change the surface tension of the molten metal metal with a globule with the metal with leaving the end of the electrode with a smaller, more frequent that helps to make molten metal more uniform, increasing the arc stability, introducing the materials readily ionize and changing them into smaller particles electrically changing the arc stream. Some of the light coatings may produce slag. This slag is quite thin and does not act in the same manner as shielded arc electrode type slag. Or your shielded arc and heavy coated electrodes. Shielded arc and heavy coated electrodes have a definite composition that can be applied with a dipping of the extrusion with electrodes manufactured with the general type of the cellulose coating with the mineral coating with the coating with the combination with the mineral of cellulose coating with the composed over the soluble cotton. Other forms of cellulose, small amount with the potassium and the sodium and the titanium, and in some cases added material with the mineral coatings that consist of the sodium silicate, metallic oxide clay, and other inorganic substances with the combination of thereof cellulose coated with electrode protect molten metal with a gaseous zone, which are arc that was well with the welded zone. The mineral coated electrode with a slag deposit with the shield arc of the heavy coated electrodes are used in welding shield and cast iron hard surfaces. Function shield arc and heavy coated electrode. The electrodes produce the reducing gas shield of the round of the arc with the prevent the atmospheric oxygen or nitrogen from contamination of the weld of the oxygen reduces combined with the molten metal with the removing the alloying elements causing porosity. Nitrogen causes brittleness, low ductility, in some cases low strength and poor resistance for the corrosion. 2. The reduces the impurity oxide, sulfur, phosphorus so that their impurities will not impair the weld deposit. 3. To provide substantively with the arc will increase the stability, eliminates the wide fluctuation of the voltage of the arc can be maintained without having excessive spatter. B. By reducing attractive force between the molten metal with the end of the electrode with reducing the surface tension of the molten metal with the vaporized with the metal coating, causing the molten metal with the end of the electrode to break up into fine small particles. The coating of the contained silicate with which will form a slag over the molten well and base metal with the slagging that solidify with a relatively slow rate, hold with the heat, but allow the underlying metal to cool and solidify slowly. The slow solidification metal eliminates the entrapment of the gas over the metal over the weld and permits the solid impurities to float to the surface. The slow cooling of the annealing effect with the welded deposit. The physical character of the welded deposit modified with incorporating the alloying materials, electrode coating, and the fluxing action of the slag will also produce the welded metal better quality, permit welding at higher speeds. Your direct current arc welding electrode. The manufacturer recommendation shall follow the specific type of electrode bees being with the general direction of the current shielded arc electrodes are designed either for the reverse low polarity electrode positive or the straight polarity electrode negative, or both, but not all. The direct current electrodes can be with the alternating current with the direct current performed with any of the type of the covered non-ferrous bare and an alloy steel electrode. Recommendation from these manufacturers also include the type of the base with the given electrode with a suitable correction for poor fit-ups and other specific conditions. In most cases, the reverse polarity electrodes will provide with more penetration with the straight polarity electrodes. Good penetration can be obtained with either type of the proper welding conditions and arc manipulation. Alternating current welding electrodes. Coated electrode, which can be used with the direct alternating current, but they are available with alternating current more desirable the welding and restricted with the area of using a high current with the required thick section because it reduces arc blow can cause the blowhole slag inclusion lack of infusion. Alternating current used with the atomic hydrogen welding and the carbon arc profit is required with the 2 carbon electrodes with a permanent form uniform rate of the welding electrode consumption of carbon electric processes where carbon electrode used with the direct current straight polarity is recommended because the electrode will be consumed at a slower rate. Lower rate. Electrode defects in their effect. In certain elements, the oxide represented the electrode coating of the arc stability will be affected, but the bare electrode composition uniformity with the wire with the important factor of the control of the arc stability. Thin and heavy coatings of the electrode will not completely remove the effect of the defect of the wire. Aluminum oxide, even with the presence of the quantity of the not exceeding 1/100% silicone dioxide, iron sulfate, cause arc to become unstable. The iron oxide, magnesium oxide, calcium oxide, and iron sulfate tend to stabilize the arc. The phosphorus sulfur present in the electrode extension excess of 0.04%. They will impair the weld metal with the transfer of the electrode with the molten metal with a very little loss. The phosphorus causes the grain of growth, brittleness, cold, shortness, brittle will below the red heat, and with the weld, the defect with the increase of the magnitude of the carbon content with the steel increase with the sulfur. Acts as the slag breaks up with the soundness of the welded metal causes the hot shortness, brittle with above the red heat with the sulfur, particularly harmful to the bare with low carbon steel electrode with low magnesium content. Magnesium promotes the formation of sound welds. 4. If the heat treatment given the wire core with the electrode is not uniform with the electrode will produce the welds inferior with the produce of the electrode, but the same composition has been properly heat treated. Solid electrode wire. The bare and solid wire electrodes are made with a wire composition required with a specific application. They have no cuttings other than required with the wire drawing. The wire drawing conduiting with a slightly stabilizing effect with the arc, but any otherwise are not consequent. The bare electrodes are used with the welding, magnesium, steel, and other purposes of the covered electrode not required with the undesirable sketch of the transfer metal arc off of the bare electrode and shown figure 811. And your solid steel electrode wire may not be bare, but they may have a thin copper coating on a wire. The copper coating can improve the current pickup between the contact tip with the electrode with the aid of the drawing and help to prevent the rusting of the wire with exposed to the atmosphere. Solid electrode wire also made of various stainless steel, aluminum and alloys, nickel alloys, magnesium alloys, titanium alloys, copper alloys, and other metals. When the wires are stationary, it can be called the welding rod. When the form of the filler metal of the welding and the brazing does not conduct with electronic current, if the wire of the electric circuit is called the welding electrode, it is defined as a component of the welding circuit through which the welding current is conducted. The bare electrode is normally a wire, however, they can take other forms. Several different systems used in identifying classification particular electrode or welding rod. It is all prefixes is used. Prefix R stands for welding rod, E stands for electrode, RB stands for welding rod and brazing filler metal. ER stands for electrode and welding rod. System identifying bare carbon steel electrode rods with gas shield arc welding is as follows. ER, your electrode welding rod indicates electrode welding rod. 70 indicates the required welding tensile strength in 1,000 pounds per square inch. S indicates a solid electrode or rod. C indicates a composite metal cord stranded electrode or rod. Your one suffix number, particular analysis usability factors. Submerged arc electrode. The system identifies solid bare arc carbon and steel with the submerged arc followed with the prefix E that indicates the electrode, with followed by the layer indicated with the level of magnesium. L for low, M for medium, H for high magnesium. Followed with the number of average amount of the carbon with the point with the hundredths of the percent of the composition. Sum of the wire with the most almost identical with the sum of the wire with the gas metal arc welding specification. The electrode wires used with the submerged arc welding give them with the American Welding Society specification bare metal steel electrode and flux submerged arc welding specification provide both with the wire composition weld with the deposit with the chemistry based on the flux used specification gives the composition electrode wire with the information given in table 8.1 with the electrodes used with the specified submerged arc flux weld welded with the proper procedure of the deposit welded metal will meet the mechanical property required by the specification. And in the case of the filler rod, the use of the oxy-fuel gas welding, the prefix R is for the valve by a G indicating the rod is expressly with the gas welding. These letters are followed with the two digits, which will be 45, 60, or 65. These designate the approximate tensile strength in 1,000 psi. In the case of the non-fierce filler metal, with the prefix E and RB are used with the following with a chemical symbol with the principal metals within the wire with the initial one or two elements will follow with one more of the alloy in contact with the chain of the element suffix letter number of the B may be have. The American Welding Society specification must be widely used with the specifying bare welded rod electrode wires. The also military specifications such as the ML-E or R type of the federal specification, normally QQR type or AMS specifications. Particular specifications involved will be used with specifying filler metal. Most important aspect of the solid electrode wire with the rods with the composition given the specification provide with limited over the specification different wire with the mechanical property requirements. Occasionally a copper plate with a solid wire with the copper with the main flake off the feed roll with the mechanism create the problems with the plug of the line with the contact tape with the light. Copper coating designed with electrode wire surfaces shall be reasonably free with the dirt with the drawing compound that can be checked with white cleaning tissue, pulling a length of the wire through it, and too much dirt will clog the liners, reduce the current pickup of the tip, and create erratic welding operation. Temper strength with the wire can be checked with the testing of the wire. The higher the strength of the feed through the guns of the cable, the better. The minimum tensile recommended specification is 140,000 psi. With the continuous electrode wire available in many different packages with the range of extremely small pool using spool guns, medium-sized spool guns, fine wire, gas, metal arc welding, closed electrodes wire available, which can be placed on reel for this part with the welding equipment. These extremely large reel weighing maybe hundreds of pounds with electrode wire available and drum with the payoff backs over the wire lead with a round container with the pulled off the container by an automatic wire feeder. Alright, 8.3, flux core and tubular electrodes. General. Flux core arc welding process made with the possible design with the electrode with the inside outside. The electrode consists of the metal sheath with the surrounding with the core with the flux allowing compound with the compounds contained with the electrode perform essentially the same function for the coating with the covered electrode deoxide with the flag formalizer arc stabilizer alloying elements that may provide the shield with the gap of the three of the region of the cold cord wire is developed and supplemented with solid electrode wire with the same with a similar analysis. This is an economic advantage. Solid wire for the wire are drilled with a steel billets. For the specified analysis, these billets are not readily available and are expensive. The single billet might also provide more solid electrode wire than needed. In this case, if the cord wire with the specific alloying elements introduced with the core material to provide with the proper deposit analysis, top tubular wire production method provides versatility with the composition is not limited with analysis of the availability of steel billets. Tubular electrodes wire easier with a welder with the solid wires so for the same deposit analysis, especially with a welding pipe in a fixed position. Flux cord electrode is designed in the sheath of the steel portion of flux cord wire compromises 75 to 90% of the weight of the electrode, with the core material representing the 10 to 25% of the weight of the electrode. The covered electrode steel represents 75% of the weight and 20% of the flux, 25% of the shown with the more detail below. More flux is used with the cover of the electrode with the flux cord wires to do the same, and to cover the covered electrode coating contained with the binder to keep the contact intact, with also containing the agents allowing the coating to be extruded. Self-shielding flux cord electrode. The self-shielding type of the flux cord electrode wires include with additional acid-forming elements from the core that necessary prohibit the oxygen and nitrogen of the air with the contact metal transferring arc across the molten weld metal. The shield of the electrode will include with the electrode the deoxidizing and nitrogating elements with the compensating oxygen nitrogen, which may contact with the molten metal. Self-shielding electrodes usually more voltage sensitive. The required electrodes stick out with a smoother operation property for the welded metal deposit with the self-shielding wires of the sometimes inferior with those produced with external shielded electrode wires because of the extra amount of the deoxidizers included with the possibility elements with build up with multiple pass, lower ductility, reduce impact value of the deposit with the sum of the codes, prohibit the self-shielding wires on the steel yielding string of the 42,000 pounds. Other codes prohibit the self-shielding wires being used to dynamically load structures. Your metal transfer. Metal train for the consumable electrodes across the arc has been classified in three general modes: the spray train for the globular train for the short circuit train for the metal train for the flux cord electrode resembles of the fine globular train for the on-cord electrode carbon dioxide shielding atmosphere for the molten metal droplets build up in the outer sheet with the electrode for the core material that appear with the transfer independently with the surface of the welded pool at low currents droplets for the 10 with the larger with the current density with the increase with the transfer of the more frequent with the smaller drops over the current with the increase with the large droplets with the lower current causes a certain amount of the splashing action at the enter and when they enter the welded pool. The action with the tree with the small droplet side with the explained with the less visible spatter. The arc appear with the smoother with the welded deposition efficiency with its higher with the electrode U with a higher current rather than lower end of the current range. Alright, mild steel electrode. Carbon steel with electrode, copper American Welding Society specification. Carbon steel with electrode, flux cord arc welding specification included with electrodes having non-appreciable alloy content with welding mild and alloy alloy steel. The system of identifying flux cord electrode with the following same with the pattern with the electrode with the gas metal arc welding, but specifically tubular electrode. For the example, the E70T1 with the indicator the electrode. E is the electrode 70 indicator the minimum welding tensile strength with 1,000 pounds per inch. T indicates tubular fabricated flux cord electrode, and 1 indicates the chemistry with the deposit of the weld with the gas type of the its usability factor. Classification of the flux cord electrodes. E60T70 with electrode classification. Electrode classification used without the externally with applied with a gas shield with maybe with a single to multiple pass application with the flat horizontal position due to low penetration and other properties well as deposit low sensitivity to cracking. E60T8 electrode classification. Electrode classification used without externally applied gas shield maybe used with a single multiple pass application flat horizontal position due to low penetration and other properties with the well deposit low sensitivity of cracking. The E70T1 electrode classification designed with the UV carbon dioxide shield and gas single multiple pass welding with a flat position horizontal fill with a quite accurate arc high deposition rate with low with a spare loss with a flat to slightly convex with a wave configuration easily controlled with the removal of the slag of the characteristic of the glass. E70T2 for the electrode classification. The electrode classification are used with the carbon dioxide shield with the gap designed primarily for the single pass weld with a flat position for a horizontal fill. However, the multiple pass weld can be made with welded beads and a heavy and appreciable amount with a mixture base and filler metals occur. The E70 T3 with the electrode classification. Electrode classification used externally with applied with a shielding gap intended primarily for the depositing single path with a high-speed weld in flat horizontal position, light plate with a gauge thickness base metal, but they should not be used with a heavy section for the multiple pass application. E72-4 electrode classification. Electrode classification used without externally applied with a gas shield that may be used with a single multiple pass application flat horizontal position due to low penetration and other properties, well deposit low sensitivity cracking. E70T5 electrode classification. Classification covers the electrode primarily with the design with a fillet group valve without externally applied shielding gas. Wells may be with the carbon dioxide shielding gas have a better quality than those with the non-shielding gas. With electrodes with a globally retained for low penetration, slightly convex bead configuration, thin, easily removed slag. E70T6 electrode classification are similar to those of the E70T5 classification, but are designed for use with externally applied shielding gas. Are your E70TG's electrode classification include with the composites of the electrode, but not include with the preceding class, with maybe without gas shield with the maybe not with the multiple pass working with maybe limited with a single pass application. E70TG with the not required with the chemical radiographic bending test impact requirements, however, they are required to meet the tension requirements of the welding current is not specified. Flux core electrode wire with considered to be low hydrogen, so the material used with the core that do not contain hydrogen. However, the some of the materials are hygroscopic. This tends to absorb the moisture with exposed with the high humidity of the atmosphere. Electrode wire with a package of the special containment to prevent this. These electrode wires must be stored in a dry room. Stainless steel with tubular welds. Flux core tubular electrode wire with available to width for the deposit with the stainless steel with the welded metal with the core for the AISI composition with the electrodes covered in the AWS specification. Flux core corrosion resistant chromium, nickel, steel electrode. With these electrodes identified with the prefix E with the file with the standard AISI code and number. The file with the letter with the T with indicate with the tubular electrode. This file with this is dashed by 4 possible suffixes include 1 indicate with the CO2 carbon dioxide gas shield with direct current electrode positive. 2 indicate the argon plus with the 2% oxygen shielding direct current electrode positive. 3 indicates no external gas shielding direct current electrode positive. 4G indicates the gas shielding polarity not specified. Tubular flux core electrode wires usually surfacing submerged arc welding applications. Deposition rate and welding quality. Deposition rate with a flux core arc with a shown figure A2 with the curves of the deposition rate with a welding with a mild low alloy steel with a direct current electrode positive. 2 type of the covered electrode with a shown with a comparison with the deposition rate with a smaller size flux core wire exceeds that of the covered electrode with the metal utilization flux core electrode is higher with the flux core electrode with the head with the much broader with the current range with the covered electrode, which increase the flexibility with the process of quantity of the deposit of the welded metal procedure with the flux core arc welding process dependent primarily on the flux core electrode wire, thus that is used. It can be expected that the deposit welded metal will be matched exceed with the properties shown with the electrode used to ensure with the proper matching with the base metal with the flux core electrode type with the shielding gas quality with the efficiency with the gap with the shielding electrode envelope of the joint detail with the cleanliness of the joint on scale of the welder quality level of the welded metal deposit with the shielding type of the electrode wire with the usually lower than produced electrode with the utilized external gas shielding. And then it shows the table in section 2 other filler metals.